What's up, guys? Now, today in geometry, we're going to be learning about something, but before we go there, let's refresh what the area of a circle looks like. Now, remember, area means space inside of something. So there's our circle. The area of it is the space inside it. Now, a formula you learned way back when, but we're going to bring it back, is area equals pi r squared. Now, that's going to play a role in what we're doing today. All right, that's the area formula for a circle. Now, that's the whole circle. What we're learning today is something called the sector of a circle. Sector just means like slice. So think about a pizza. Sector is like a slice of the pie. Right? So we're going to learn how to find the area of just a piece of our pie. Now let's see how we can do that. Well, like anything else, we need a formula. All right, so we roll it on down. Area of a sector formula is, what is it, Siegel?
It's m over 360.
So that looks the same as something else we just did.
It's a fraction.
Yep.
Times pi r squared.
And there's that pi r squared coming up, right? Because remember, we know that the area of a circle is pi r squared, but we only want a piece of it. In order to find that piece, it'd be m over 360, where m is just the measure of our angle, right? So that should make sense. A fraction is like a fraction. So here, let's see how this looks in action. Here's the first one. So, same thing as before. We always write our formula. So, the formula for the area of a sector is the m, which is the measure of the angle, over 360, times pi r squared. What do we have? Well, they gave us the angle is 60 degrees. And remember, we know it's 60 because it's a central angle, right? So they're the same. So we know that we can mark that. And our radius is 11 feet. So we know everything we need. So AS equals 60 over 360 times pi, and then our radius is 11, which ends up being squared. Now, Siegel, on this IXL also, is it the same way with the pi's or no?
Yep, same stuff.
Same stuff. So we're going to leave the pi alone. We're going to treat it like a variable. And then you just plug the rest into your calculator. And when you do that, you're going to get 60 over 360 times, what is that, 121. You're going to get a nice fraction. This one I'm not going to claim to do in my head, ladies and gentlemen. Siegel's working it out for us, and this is what he got.
121 over 6 pi.
So if it's 121 over 6 pi, remember that when you write it in IXL, you write 121 pi divided by 6. That way you get the answer right. So that's that one. If you scroll down, this one looks very, very similar, so we'll just set it up for you. Same thing, write your formula. So AS equals m over 360 times pi r squared. Our m, the measure of the angle, is 80. And our radius is 3.5 inches.
Let's just do 3.
3 is a lot easier.
Yeah, I don't want to deal with that.
If it was 3.5, ladies and gentlemen, you would just put it in your calculator anyway, but 3 will come out clean for us, for our purposes. So AS equals 80 over 360 times pi and then 3 squared. And then once again, plug it into your calculator, the 80 over 360 and the 3 squared, which we know is 9. And we're going to get a fraction.
Oh.
Maybe a clean one too. This one would be nice.
This was a clean one.
Yeah. That's why we took the half out, made it nice and easy. Oh, 2 and pi. So this answer you just put in as 2 pi. Comes out perfect. So yeah, so that's the area of the sector. So that means that area in there is equal to 2 pi. Siegel gets an A for coloring. Here we move on to the next one. And like the arc length problems, they can give you some information and you have to work backwards. And this one is saying find the radius. So let's write our formula again. So we have AS equals m over 360 times pi r squared. And now here, if you look, they actually gave us the area, which is that 88 pi. And then they gave us the angle of 165. So for AS, we're actually going to plug in the 88 pi because that's the area of the sector. The measure, the m, is going to be 165 because that's the angle over 360 times pi r squared. And from here, we can cancel out the pi on each side. And so now we just have 88 equals 165 over 360 r squared. And here we don't like denominators, so we're going to multiply each side by 360 to get rid of that nasty denominator. 360s go away on the right. 360 times 88 is going to be a big number that Siegel's going to tell you here in a minute.
All right, here, let's bring it over here. So 31680.
31,680 equals r squared. Oh, I was jumping ahead. I'm trying to get that done so fast. And then we divide each side by 165. You'll get another big number. Yep, I can do this. And I can move this guy down. There we go. Give you a little bit more room.
Okay.
Oh. There.
All right, so we get R
Yep, now you're good.
equals 192.
And then to get rid of r squared, we have to take the square root. So square root both sides. And you end up getting r equals square root of 192, which works for us.
Yeah, you can't simplify it, so.
Oh, yeah. And if it was an IXL question, I'm sure they would ask you to round to the nearest hundredth or something along those lines. Go to 19 as well, or set it up for them, or?
Yeah, we're good.
We're good? All right, guys. Good luck, and we'll see you next time.